Namaste everyone. In this video we'll be solving a problem on kinetics. We have a train here which is weighing as 3000 kilonewtons, moving on a track which is sloping upwards. Slope has been given as 2 by 100. It's moving up with an acceleration that is 0.04 meter per second square under the tractive resistance of 6 Newton for every kilonewton of normal reaction. And we have been told to find the accelerations when the train is moving on a horizontal track and when the train is moving downwards on the same slope. Let's call these as A1 and A2. In order to find these, first we will have to find the force with which the train is pulling itself. And to do that, we'll have to take the free body diagram of the train and apply all the forces acting on it. Weight will be acting downwards, normal reaction will be acting perpendicular to the slope, and the tractive force, the resistance, will be acting parallel to it. And of course there will be a an inertia force acting opposite to the direction of acceleration. For reference purpose, we'll be taking this perpendicular line as y-axis and this parallel line as x. The angle here will be same as the angle which is here. That angle will be equal to tan inverse 2 by 100. When we calculate it, we get that angle as 1.146 degrees. Now we can apply the equations of equilibrium because as per the D'Alembert's principle, we have considered the inertia force. First, let us take sigma y, which is the components of all the forces in y direction. So here we get r in positive y direction and the component of 3000 opposite to the y direction. Now because it is in equilibrium, sigma y will be equal to 0 and we get the value of r as 2999.4. This is of course in kilonewtons. Next, let us apply sigma x, the sum of all the components in x direction. First force is P acting in positive x direction and there are a lot of forces opposing it. First among them is the inertia force, then we have the tractive force, and finally the component of weight, which is this much. Once again the sigma x has to be equal to 0 because it is in equilibrium, and we get the value of P calculated as Fi plus Fr plus the component of 3000. Now let us put all these values one by one. Inertia force will be mass, which will be 3000 by g multiplied with acceleration. Fr is the friction force, which will equal the tractive resistance of 6 Newton by kilonewton multiplied with the normal reaction, which is 2999.4. And finally, of course, the component of weight. While applying this equation, we need to be slightly careful because this value is in kilonewton. Here the kilonewton is getting cancelled and here the value is in kilonewtons. So this value technically is we are getting it in newtons, and so to convert it into kilonewtons we need to divide this by 1000. Substituting all these values in the calculator, we get the value 90.23 in kilonewtons. So this is the force with which training is pulling itself. Now using this force we will be able to find the acceleration for the train when it is moving on a horizontal plane. So let's rotate this diagram till we get our track horizontal. Now here we get the force with which train is pulling, same as what we calculated above, and we need to find the acceleration A1 that the train is able to move with. Once again, let us take all the forces that are acting on this free body diagram. The downward weight will be acting downwards, then there is a normal reaction here, let's call it as R1, and of course there is a friction force which is acting backwards. And finally, to bring it in equilibrium according to D'Alembert's law, we have to apply the inertia force in backward direction. So here we can go ahead by taking the reference planes as horizontal and vertical. So first let's apply the equation of equilibrium for vertical components, which gives us downward weight of 3000 kilonewtons minus resistance R1. both have to be equal to 0, which gives us the resistance value as 3000 kilonewtons. Applying the equation of equilibrium for horizontal components, we get the force which is moving the train P minus inertia force which is acting backwards minus the friction force. The sum has again got to be equal to 0 because we have brought it in equilibrium. The force P is 90.23 minus inertia force is 3000 by g times acceleration minus the friction force, which can be obtained by the tractive resistance multiplied with the normal reaction, which in this case is 3000 kilonewtons. Once again, we need to be a bit careful here because these two values we are getting in kilonewtons, and here if we cancel this, we'll get this in newtons. So instead of cancelling it like this, let us cancel this Newton alone and we get kilo in the bottom, which means this kilo will get cancelled with the 3 zeros. So in this equation, A1 is the only unknown which we can find by sending it to the other side, which will come out like this, and then A1 will be equal to this value here into g by 3000. So when we put that in the calculator, we get 0.24 meters per second square. So this is the acceleration with which the train is able to move on a horizontal plane. Next, we will have to find the acceleration in the same train when it is going down the slope instead of up the slope. The slope is same, so this angle here becomes theta, value of which will remain same as before. Now once again, we will have to take the free body diagram of the train. Weight will be acting downwards as usual. Force P with which the train is pulled will act parallel to this plane. The normal reaction will be perpendicular to our plane. Resistance will be acting in the backward direction here. And because the acceleration will be acted in the downward direction of A2, the inertia force will be acting here in backward direction. Let's take reference planes as x and y once again, this being x parallel to the slope and this being y perpendicular to it. The angle here will be same as theta again. Now since we have considered all the forces along with the inertia force, by D'Alembert's principle this body is in equilibrium and we can apply the equations of equilibrium. First again we will take all the y components. Let us say the reaction is R2 here. So R2 will be in upward direction and the component of 3000 will be opposite to it. Because this total is equal to 0, we will get the value of R2 as 3000 into cos theta, which will come out as 2999.4 in kilonewtons. Next, let us take all the x components of the forces. Let's take the downward direction as positive and backward as negative. P is acting in the downward direction, so positive. Then the component of weight will also act in the same direction. So that's got to be 3000 into sine of angle theta. Inertia force, however, is acting in the negative side, so minus. And the friction force is also acting in the negative direction. The sum of all these components again has to be equal to 0 because the object is in equilibrium. Now let's find the force P. The force P is same as before, which is 90.23. So let us substitute that 90.23 in kilonewtons plus 3000 kilonewtons into sine of angle, which is 1.146 degrees, minus Fi, which will be 3000 kilonewtons by g into the acceleration, in this case A2. Finally, minus the friction force, which will be the tractive resistance 6 Newton per 1 kilonewton into the normal reaction, which in this case is 2999.4 in kilonewtons. Again, we can find all other values are in kilonewtons except for this value here. So let us just cancel the Newton over here and we'll have kilo at the bottom, which means we'll have to divide it by 1000. Now all the values are in kilonewtons and we can use this equation correctly. We are interested in finding the value of A2, the acceleration. So let's send this term over to the other side. So we get 3000 by G into A2 on the other side. And the other values, when we add them up, we get 132.23 in kilonewtons. So now we can easily find the acceleration by putting it in the calculator. So we get 0.43 meter per second square. So that completes our problem. So we have found both the accelerations over here. Now comparing it to the initial acceleration, we find that the acceleration has become 6 times of the initial acceleration just when the slope changes from upward slope to horizontal. And you can see that it has become 10 times if the same slope is reversed. So there is a lot of importance of the slope here. We see that the acceleration is actually getting 6 times or becoming 10 times depending on what is the slope. So hope you have understood this problem. In the next video, we'll take up another problem. Until then, goodbye.